Hi, hello to everyone. Welcome back to Learn at Home channel. This vector calculus is a short topic, but it has more important things which will definitely come to your exams. Okay, this vector calculus has two things, like two divisions: vector differentiation and then vector integration. Under this differentiation, there are three topics like gradient, divergence, curl. Okay, here line integration, surface integration, volume integration. Okay, these six topics are very important, and definitely there will be sums from these topics. So vector calculus is just a simple topic, but it has more important sums. Okay, let's see that. Scalar function. What is scalar function? A function is defined at each point in a certain domain D in a space. So a function at each point, its value is real and depends on the point in space. This is nothing but a point in a domain. So it has a real value. This value always depends on this point in the domain. Okay, but not on any particular coordinate system. It does not relate to coordinate system. Okay, mostly the scalar function does not have the direction. It only has the magnitude value. Okay, what is vector function? A function like v is a vector. This vector has a magnitude and a direction. See here, I, j, k. These are directions. v1, v2, v3. These are magnitude values. And this arrow represents the vector symbol. If we put arrow, means this will have both magnitude and direction. Okay, so a function, this vector defined at each point P in the domain, means, so this P, which is nothing but the vector. Okay, this P is nothing but the scalar. Next, vector function. You can see here 3x square y. This is a magnitude value. 3x square y z. I vector is a direction. So magnitude and direction combine to form the vector function. Vector differential operator. What is this? This is nothing but delta. Okay, delta means we need to differentiate with respect to x or y. Okay, x and y. If it is 2D, means dou by dou x, dou by dou y. We need two terms. If it is 3D, means three terms. Okay, generally this symbol is nothing but the delta. So vector differential operator is for 2D, I into dou of some functions. If f is a function, means if f is said to be a function of contains x, y, means you need to put f here. Okay, so dou by dou x into I, dou by dou y into j. If 3D, just add dou by dou z as here. Okay, del square means dou square by x square. Why it is, means I square. Can you see that? I vector square is nothing but 1. The same applies to all. J vector square is 1 and k vector square is 1. Okay, so these all become 1 means only we have dou square by x square plus dou square by y square plus dou square by z square. That's it. And another thing, this del square, if it is multiplied to a function means it will give a scalar value. Okay, del square of function means pi. What is this? We need to differentiate 2 times this pi function. Okay, this pi function should be differentiated by 2 times. That's the meaning here. Like with respect to x, with respect to y, with respect to z. Okay, so del square of function always gives the scalar value. Okay, and this function is nothing but the Laplace equation. Laplace equation. Del square of function is called Laplace equation. If any function that satisfies this Laplace equation means that is harmonic function. Harmonic function. Okay, so if any function will satisfies this equation means harmonic function. This equation is nothing but Laplace equation. Okay, okay. There comes the vector operations. Okay, some operations are there, like how can I add or subtract or multiply the terms which has the vectors. Okay, let me say A is a vector, so it has a1, a2, a3 with vectors I, j, k. So a1 into I, a2 into j and a3 into k. These are the vectors and magnitudes. The same applies to B here. Okay, so if I said A plus or minus B, if I said vector A is plus or minus to vector B, like if I add to these two vectors or if I minus these two vectors means I can write it as just do the calculation with the magnitude. Okay, magnitude value like a1 plus or minus b1 into I. I is nothing but the vector, I vector plus the first term, and then the second term a2 plus or minus b2. If it is addition means just add all the magnitude values and then put vectors as well as same. Okay, if it is in a dot is nothing but a magnitude. A dot b, we will always say a dot b. This will be a into b. Okay, a into b means this is the formation of vector product. If it is a scalar product, we need to say only dot. Okay, scalar product is what? Only the magnitude value, because in scalar there is no direction, right? So in scalar product only the magnitude we need to product it. Okay, in vector means we should include both the direction and magnitude. Okay, so we need the matrix here like determinant of I, j, k. These are the vectors and the like the A magnitude and then the B magnitude. If we solve this, we will easily get the product of A vector and B vector. Okay, if A dot B, I already said it is the scalar product like magnitude values. Okay, so likewise here A dot B, which is also equal to mod, this is mod A vector into mod B vector cos of A vector dot B vector. Okay, so A dot B means just include cos here. Modulus of A vector, modulus of B vector into cos of A dot B. If it is into like vector product means A vector into B vector, it is a vector product. If it is in this condition means just write sine instead of cos and then include an unit vector. here. Okay, this is important. This is nothing but the unit vector like n cap. Okay, this symbol is named as cap. Okay, this is cap. Okay, next comes scalar triple products. We only say the product between the two variables, but here we have three variables. How can I product it? A cross B dot C. Okay, A cross B dot C, that is, this is vector and this is scalar product. If it is in this condition means I can write it as, just take the A out and combine B cross C. So A dot B cross C, I can write like this. This is nothing but a box of A, B, C, like I need to take the determinant value. Okay, so I need to take the determinant value here. So A cross B dot C means I can easily write it as A dot B cross C. This is nothing but box of A, B, C. Okay, A vector, B vector, C vector. Right? What is the magnitude of A vector? I need to find the magnitude of A vector means nothing but a modulus of A. Modulus of A means what? I need to square the each magnitude here. A1 square plus A2 square plus A3 square. So this will done with the help of, like, this will be done with the root, right? So root of A1 square plus A2 square plus A3 square, right? So A vector has three vectors, I vector, J vector, K vector, right? So I need to square those magnitudes and then within the square root. Okay, this is the modulus of A. Okay, and then what is volume of parallelopipe? Which is nothing but the box of ABC, right? So I need to take the determinant value for the box of ABC, which is nothing but a matrix, like, okay, volume of tetrahedron, just 1/6 of parallelopipe volume. Okay, A vector, B vector, C vectors are edge vectors in the parallelopipe. These are the parallelopipe edge vectors. Okay, vector triple product. You can see here there are two crosses. Okay, here there is only one cross and dot. Okay, if there are two crosses means you have to go always in this direction, like anti-clockwise direction. Okay, only single element will be in outside. So I can easily write this A cross B cross C means, which is equal to, I need to go from here to here. Don't forget that. Okay, you can't write C dot A as A dot C. Okay, this is wrong. You have to write C dot A. There is no other option to interchange those elements. Okay, just concentrate on this. A cross B cross C. So I need to first combine the C with A into B and then C with B into A. That's the thing here. C dot A into B minus of C dot B into A. Okay, the same applies here. You can see here A cross B cross C. Don't come here to here like clockwise direction. You need always to take the anti-clockwise direction, like C dot A into B, B dot A into C. Okay, don't interchange these elements. It will give a wrong answer. Okay, unit vector along the direction of A vector means, so there is a point here. Unit vector is nothing but n cap, right? This is nothing but the n cap. So the formula for n cap is nothing but a vector by the modulus of that vector. Okay, so you can see here unit vector along the direction of A vector. So I need to find the unit vector for A vector means, just A vector by modulus of A vector, that is magnitude of A vector. Okay, I need to find only the magnitude. If I take modulus means I will get the magnitude values. Next, angle between two vectors, A vector and B vector. So let's say these two are two vectors. I need to find the angle between these two vectors. Cos theta, which is equal to A dot B, A vector dot B vector by modulus of A vector and modulus of B vector. Okay. So cos theta, which is equal to A vector dot B vector by modulus of A and modulus of B. Okay, this is the angle formula. Okay, if we need to find the angle between the two vectors, this is the formula. Vector differentiation. What is this? It is nothing but, let me say, r vector of t function. So r vectors has t function, which is equal to f vector also has the t function, means vector can of the curve than dr vector by dt vector. So this two things are equal, means these can be the vector of the curve than dr vector by dt. Okay, so this is the main thing. Dr vector by dt is nothing but it is the vector of curve. Okay, so dr by dt, which is equal to limit the del t, which is nothing but the change in time. So del t tends to 0, means f vector of t plus del t minus f vector of t by del t. So you can see here, this is r and this is vector. So in terms of, just the question is r, but I am writing it in terms of f, because r vector, which is equal to f vector. Okay, so I am writing it as dr vector by dt, which is equal to limit, if there is a change in time, del t which tends to 0, means f vector of t plus del t. So just add del t here, minus f vector of t by del t. Okay, we need to subtract these two things. If we subtract, means we will only get the del t here as in the denominator. If t is time variable, nothing but time changing, then dr by dt represents a velocity vector. If there is a time change, means it will represent the velocity of the vector. Okay, there is some notes like dr vector by dt is a vector in direction of tangent. Tangent is what? If there is a curve, like I will say to you, if there is a curve, this is a parabola curve, means if there is a curve, if there comes a line, okay, if there comes any line which touches the curve, means this line is said to be the tangent line. This line is nothing but the tangent line. Okay, so dr vector by dt vector is a vector. Okay, so dr vector by dt is a vector in direction of tangent. This is in the direction of tangent to the curve. So this is a tangent to the curve. In that thing, dr by dt is a vector, means at any point, means like this dr by dt is a vector in the tangent which acts as a tangent in a line which acts as a tangent to the curve at that point. Okay, this is the thing. So dr vector by dt is a point on a line which acts tangent to the curve. Okay, f vector of t is constant in magnitude. So f vector function has t, right? This f vector function is of, like, this f vector is a function of t. Okay, so f vector is a function of t means is constant in magnitude. Means this f vector of t can be written as f vector into the differentiation value df by dt. A vector into a differentiation value will be equal to 0 only when this vector's magnitude is in constant. The same applies here. You can see here f is a vector which has t function. Okay, with fixed direction, if this vector has a fixed direction means then f vector cross d differentiation of that vector with respect to time, which is equal to 0. So here cross, if cross came means there is a fixed direction, fixed vector values. If dot came means there is a fixed magnitude value. Okay, it's a constant magnitude value. This is the same. This is a vector. If we differentiate this vector with respect to t, and if we multiply it means which is equal to 0 only if magnitude or f vector is in a constant or fixed values. Okay, there are 3 notes here. And let's go to the properties. Let a vector with function t, a vector and b vector be the vector functions of the scalar variable t. These are scalar variables, like, okay, and pi be the scalar function. This pi is a scalar function means then differentiation of these two vectors in the plus or minus will be equal to, we can write this as in the individual differentiation. And the same applies here. If it is a dot b means just multiply this thing to means we need to write it in 2 terms, right? So just multiply this d by dt to a vector and then into b, and then a dot, then differentiation to the b. So b db vector by dt. This is like u v the whole dash, like first derivation, which is equal to u dash v plus u v dash, right? So what is u dash? U dash is nothing but a, and then b is v, right? So u dash means we need to differentiate the a value. So dA by dt dot b into, plus a vector dot, we have to differentiate the v, right? So a dash b plus a b dash, that's the thing came here. This differentiation, first derivative with respect to t. Here you can see here a cross b. If we differentiate this, a cross b means the same, the only cross will be the difference. If cross means put cross here, if dot means put dot here. Okay, and the fourth property is differentiation of pi of a vector. Pi is nothing but a scalar function, right? It is a scalar function. So pi is nothing but the scalar function, which is equal to, just multiply as I said, right? So this is u, if you take this is u and v means u dash into v plus u v dash. You can see here, that's the thing here. Next one, r vector which is equal to f1 of t I vector plus f2 of t j vector, likewise. This is a positive vector. Means if this is a positive vector means we can directly differentiate this r vector, we will get the velocity. If we again differentiate this means in the second differentiation we will get the acceleration. only when the r vector is a positive vector. Okay. Next one, unit tangent vector. What is this unit tangent vector? This is nothing but, what is the meaning for unit? Unit means we always put the vector by vector modulus, right? Means like n cap. Just remember n cap, which is equal to what? A, which is equal to a vector by modulus of a vector, right? So a vector by its modulus, that is nothing but unit vector. But here unit tangent vector, what is this? Which is nothing but there is already a differentiation in the vector. So just take this as a vector means a by modulus of a, right? But a is what? The a vector is already in a differentiation. So this implies the tangent vector, unit tangent vector. Dr vector by dt by modulus of dr vector by dt. Okay. Next, gradient of the scalar function. So what is the gradient? If pi is a function which has x, y, z, means this pi is a scalar function. We already seen that. So gradient of pi, we can easily write it as del of pi. Like we need to differentiate each term by x, y, z. That's the thing here. So gradient of pi, which is nothing but I vector into dou the function pi by dou x plus j into dou pi by dou y, the same, plus k vector into dou pi by dou z. This is the gradient of pi, gradient of any function. Okay, just we need to differentiate with respect to x, y, z, the respective magnitudes. We should include these vectors also. Gradient of a scalar point function is vector function. How can I say that? Because I am just including I, j, k, right? These three are what? Vectors. So gradient of scalar function is a vector function. The gradient of any function will be a vector function. Gradient gives normal to the surface. It is always a normal. This is always normal to the surface. Okay. Unit normal, like unit vector, as we already seen that a vector by modulus of the vector, right? So here n cap, which is equal to del pi by del pi. We can easily found this for gradient pi by modulus of gradient pi. We can easily say this as a unit vector. Unit vector. Okay. Unit vector normal to surface. This unit vector is always normal to the surface. Okay. What is level surface? Let pi be a function. If this function is in the scalar field of region R, means then the set of points which satisfies this function, which is equal to C, means which constitute a surface, like level surface. So a set of points which are in the scalar field in region R, okay, which satisfies the condition, the function should be equal to a constant. If these points satisfies this condition, means then there forms a surface called a level surface. Next one, gradient of pi. So this is a question. Gradient of pi, they have given a pi function at 3 points. What is the gradient? Gradient, which is nothing but del pi, right? Del pi is what? I need to include I, j, k. And also, I need to differentiate this function with respect to x, y and z, right? So, what is the first term here? X is there. If I differentiate the first term is what? Dou pi by dou x. Dou means what? If I need to differentiate with respect to x means the other two variables will be a constant. That's why I am putting dou here. Okay, let's differentiate all the things. With respect to x means what? 6x into y because y is constant. This only term will come. So, I vector into this function plus j vector into the same with respect to y. 3x square minus 3y square, right? So, we need to put the power before and minus 1 in the power. This is the differentiation. Into z square plus there is still some z function, right? Means there is still more to do, like we need to differentiate it with respect to z. So, k vector into this is already it has minus. So, minus 2z into y3. So, this is the gradient. Just what to say, they have given 3 values here, like 1 point here. This is nothing but x point, y point and the z point. Just substitute these points here, you will get a normal vector, that is gradient of this function. Okay. If they asked unit normal vector means just take this vector as del pi by modulus of del pi by we need to we need to square the magnitudes. Like here you can see there is 6. 6 means 6 into 6, 36. 9 nines are 81. 4 fours are 16. So, we need to write their magnitude values in squares. Okay, so the answer is root of 133. Okay, next comes angle between two vector problems. Okay, let's see one by one, and there comes 2 points here, like angle between two curves. So, there are 2 curves, like this is the upper curve and this is a lower curve, means like there are 2 parabola curves, right? So, the angle between 2 curves is angle between their tangent at common points. So, 2 curves means the angle between their tangents at common points. If the angle between 2 surfaces is angle between their normals. So, surface means what? Normal. Okay, surface means normal. If it is curve means there will be one tangent, right? So, if it is curve means this is tangent. So, angle between 2 curves can be found by taking the angle between the tangents at any common point. The same applies here. Okay. Next thing. Find angle between 2 surfaces. So, they have given 2 surfaces and 1 point. Let's take this function as 1 and this function as pi 2. We need to find the angle, which is nothing but del pi 1 in dot del pi 2 by modulus of this function, first function, into modulus of the second function. Okay, this is the formula for angle between 2 vectors, right? So, we will do the problems here. A, B are 2 arbitrary vectors. We know that with respect to A, B, like, wait. Actually, I have written the question here. Just solve this question. Just take a del value to the pi 1 and pi 2. What is the del means? Which is nothing but we need to differentiate each term and put I vector, j vector and k vector to the each term. Okay, then only we can get the del of pi 1 vector. Okay, there comes the second sum, like a, b or arbitrary vectors with magnitude a, b respectively. Then we need to find a cross b the whole square. We know a cross b is what? If they asked a cross b means I need to check with a cross b, which is nothing but a vector b vector into sin a vector dot b vector into n cap. If I square this term means modulus of a vector will become a square b square and sin square theta. We can easily write sin square theta like 1 minus cos theta, because sin square theta plus cos square theta equal to 1. So I can write 1 minus cos square a vector dot b vector. And what's the value which includes cos? This is the formula which includes cos, like a cross b, which is nothing but modulus of a into modulus of b into cos of a dot b, right? There comes the cos. Just take, okay, just take here. So what is the value? So what is the value here? I can easily write this term means I need cos, right, for this equation. If I need cos means I can easily write a cross b into a vector into b vector. Like if I square means this cross will become dot. So a dot b the whole square, which is equal to a square and b square. This is in terms of cos of ab. So the modulus of square, the modulus square will be the same number. So a square, but it is not in a vector. This will come as a scalar. So just take the LCM here and you will get the value. Next, properties of gradients. There are some properties. Del of two different functions are added means we can write it as a separate function. The same applies here. Del of C1 into F plus C2 into G. Like these are two constants and these are two functions means we can write this as U dash V plus U V dash, like C1 into del pi plus C2 into del G. Okay. And then del Fg. Okay, if I need to write del of Fg means F into del G plus G into del F, just in a reverse order. Like if the del value is in fraction means del of F by G. There are two functions which is in division, right? So F by G, which is equal to G of del T minus F of sorry, these are dels. Okay, I just write the opposite symbol here. So this is also a del. Only del is here. So G into del T minus T into del G by G square, where G is not equal to 0. Let us say R vector is some vector form. X plus ij, y plus y means x plus I plus y into j plus z into k, right? So I need to find the modulus. Modulus is nothing but square root of x square y square plus z square, which is equal to r. But if I put square in these two terms means it will become the square root will be get cancelled and r square will be equal to x square plus y square plus z square. In this thing, I need to differentiate this r with respect to x. Okay, I need to differentiate this r with respect to x. This differentiation should be done to the scalar, not to the vector. So I need to differentiate this, means I need to differentiate the r. Okay, I need to differentiate the r with respect to x. Like you can see here, if I differentiate this means 2r, right? 2r, the power will come to front. 2r into dou r, which is equal to 2x into dou x. But here you can see these twos are constant and it will be eliminated. Likewise, just see here, I need dou r by dou x. So just rearrange this thing, you will get x by r. Like this, you can easily write here the other two things. How? Dou r by dou x is nothing but the reverse order, x by r. If dou r by dou y means just a reverse order, y by r, z by r, that's it. So the first point, gradient. So these are the questions. Okay, we need to find the things. Okay, which is this or so from this it is like a problem, but it concludes, means it includes a lot of properties also. Okay, let's see those things. So what is this, let's concentrate on this. First point, they have asked a gradient of r. Gradient means what? Del. Okay, so always remember gradient means del of r vector. Okay, r vector. Like we know, if I say del of r vector means del is nothing but dou by r, dou by dou x, dou by dou y, dou by dou z. But we know the value, right, for the r function, r vector. So I can directly write dou r by dou x is what? X by r. So x by r I vector plus y by r j vector plus z by r k vector. You can see here del r vector, which is nothing but we can directly write these three values here. Okay, then you can see here these three r's are common. So I am just taking these r's as a single one. Okay, you can see here this is feels like r vector, right? What is the r vector? Which is nothing but x I vector plus y j vector plus z k vector, right? You can see here this term will be the r vector. So del r vector, del of r vector, which is del r vector, which is equal to r vector by r. Likewise, they have asked another question. So you can see here gradient of r is nothing but r vector by r. Now we are going to find for 1 by r, gradient of 1 by r. So if gradient of 1 by r means we need to put del of 1 by r, right? So here we done this for only the single r. So we need to start from the first steps, like dou by dou x of 1 by r into I vector. This is the function, like this is the vector. So we are differentiating it. Okay, so the vectors can come in this differentiation only. The differentiation is applicable for the vector only with ijk. Okay, so dou by dou x of 1 by r into I. So likewise we can write these things. How can I differentiate 1 by r? Like we need to minus 1 to the power and we need to bring that power to the upper side, like to the numerator with a simple minus. So minus 1 by r square into What is this? This is r. So dou r by dou x into I vector minus 1 by r square into dou r by dou y, because we are differentiating r vector with respect to x, right? So we need to write that. So after writing these things, you can see here we know the value x by r, y by r, z by r, right? So just write those values, and you can see here these are r cubes. So I can easily take out the r cubes, which is equal to r cube, like as you know, I can write it as a single term. So minus of r vector, this is nothing but r vector. So xi vector plus yj vector plus zk vector. So minus of r vector by r cube. So you can see here gradient of 1 by r is nothing but minus of r vector by r cube. Okay. Then we will move on to the next one. Gradient of e power r square. Okay, what is this? Gradient of e power r square. So we need to first differentiate these things, right? So I am just writing this r e power r square into, like I am just differentiate these things. E power x is what? E power x. But if I have e power r square means first write the same term here and then differentiate the power, like e power r square into, if I differentiate r square means 2r. This is common, right? So I'm just written this term as outside, because if I do the things means like this term into dou r by dou x, again this term into dou r by dou y. So this term will come in every terms. So I just taken this term as common, and if I take this common means I will get some values here like dou r by dou x. So I can substitute those values. You can see here this will become r, right? So I can take the r outside, and 1 by r is nothing but r power minus 1. So if this r came out, and you can see 2r is already here, so this r will get cancelled. So 2 times of e power r square into the r vector. Always remember 1 by r is nothing but r minus 1, r power minus 1. So I just written the 3 properties here, like 3 questions, and you can remember all these things. Always remember these things, okay? Gradient of r is r vector by r. Gradient of 1 by r means minus, you need to put minus here, minus r vector by r cube. Then gradient of r square means just put 2 before, 2r vector. Log r means r vector by r square. You can see here only single r vector by r. Log r means r vector by r square. 1 by r means it will become q. N means it is nothing but you need to put the power before and minus by 2. That's it. So r power n, gradient of r power n means n into r power n minus 2 into r vector. Always r vector will come in every answer. Okay. Next, gradient of e power r vector. We just now see that 2 into e power r square into r vector. That's the thing. Next comes the directional derivative. This is also an easy one. Just concentrate on this. Directional derivative means I can write it as dd. Okay. So the directional derivative of a surface pi. Let's take the surface as pi. In the direction, the surface pi has a direction or vector means this directional derivative can be written as del value of pi into unit vector, because it has some vectors, right? So I have to include unit vector. You know that unit vector, which is nothing but r vector by modulus of r. Okay. So directional derivative means del pi. Gradient means only del pi. But in case of directional derivative, we need to add n cap here. Okay, it has the maximum value where at del pi direction. So whatever the del pi follows, it will follows. So the del pi follow in a direction means in that direction that directional derivative will have the maximum value. What is that maximum value? Which is nothing but delta, like determinant of this del pi, this value. So this value, this dd always follows del pi. Okay, just remember that. The directional derivative of f function, they have given one function. Let's see some example of this dd. Just only one example. F function is, they have given 2x square plus 3y square plus z square. This function is at point. So they have given one point here. In the direction of vector A, they have given this direction here. So the direction is nothing but the n cap. So from this vector, we're going to find the n cap. Let's see how the things are going. Okay. So first, for the first thing, I need del f, right? Because they have given the function f. So you can see here what is the function? 2x square, 3y square, z square. Okay. What is the function? 2x square, 3y square, z square. Like, I will write the function here. What is the function of f? Which is nothing but 2x square plus 3y square plus z square. So by differentiating this f with respect to x, y, z, let's see that. If with respect to x means these two constants will get 0. So this 2 will come in front. So 4x. Likewise, 3 2s are 6, right? So 6y plus this 2 will come front. So 2z. So I just differentiate this function f. Okay. And I have written the ijk because this is a vector function, right? So I can easily write del f vector. Okay. So they have given one point. Why they have given one point? Whatever the thing. If the question has some points means just substitute these points in place of x, y, z. So this is nothing but x, y, z. So I can easily substitute the values. I have got the value as 8i vector plus 6j vector plus 6k vector. This is nothing but del f vector. So what is the thing here? Always like in the previous sum we have seen unit vector which is equal to del f vector by del means modulus of that vector. But here they have given a separate vector for the direction. So this unit vector is nothing but the directional vector. This vector is represented in the question as direction vector. Okay, if the direction vector is given means just move on to the, just take this vector and substitute in the n cap. So what is the n cap? A vector by modulus of vector. I just wrote the a vector here. And what is modulus? Magnitude, square root of magnitude square. Okay, plus the another magnitude like 1 plus 4. That is magnitude. After you can see here this is 5. So root 5, 1 by root 5 into the vector. Okay. So this is the dd, like directional derivative. Okay. This is also an important one. Okay. So dd, that is del f vector into n cap. Okay. Into n cap. So we need to find the dd, right? Up to this we have found del f vector and n cap. So just multiply it, you will easily get the value. How? You can see here f vector del f has ijk, here ik. So just remove the k because there is no there is no j here. So 8 into 1, just multiply the coefficients of I. 8 into 1 and 6 into 0, right? There is no coefficients. 6 into minus 2. That's the thing I have written here. The same 1 by root 5. So we will get the answer. So it's dead easy. You can't write all these steps. Just remember and just wrote only a quickest step. Okay. Just find del f means del f vector and then find n cap. Multiply it. You will get the directional derivative. Okay.